All right, we're back again for another Ohio State test standard review. Today we're talking about standard 8.F.5, which is more about interpreting graphs and functions and all that fun stuff. Let me clear out my calculator and we'll hop right in. Christy drives from Columbus, Ohio to Cincinnati, Ohio. Match each graph to the quantity which would best represent the value of y with respect to time in minutes during Christie's drive. So what they're saying is that your x will always be time. As time goes on, what is happening? Okay? So we're going to talk about amount of gas in the gas tank. Okay? So let's think about how a trip from Columbus to Cincinnati would go. You would have to drive for a bit, driving, and you probably have to stop for gas, especially if you didn't start with a full tank of gas, which, if you're going on a road trip, start with a full tank of gas, right? So your gas will be going down. It's going to get lower and lower and lower until you get to that gas station, in which case it's going to go back up. And then it will start to decrease again as you continue to drive. So look at these three graphs and tell me which one of these graphs you think represents that. Your gas gets lower, lower, lower. You get to the gas station, you fill it up, and then it starts to get lower and lower again as you continue to drive. So for me, that would be this one. Here's where you're starting. You're driving. Here's where you get to the gas station. You fill up your car, and you're back up here, and you're driving. Your distance from Cincinnati, okay? So, this one requires a little bit of thinking. You're starting in Columbus, and you're going to Cincinnati. That means that at your starting point, that is the farthest away you should be from Cincinnati, barring detours, right? That is the farthest away you should be from Cincinnati. And then as time goes on, you should be getting closer to Cincinnati before eventually arriving in Cincinnati. That's the goal. So which of these graphs represents that? I would say it's this one. Because, like I said, you're starting the farthest away from Cincinnati that you are. And you're getting closer. Here's probably where you stop to get gas again. So you're not moving for a bit, and then you get closer and closer until finally, huzzah, you've reached Cincinnati. Your distance away from Cincinnati is 0. So process of elimination for this last one, distance from Columbus. You're starting in Columbus. Your distance from Columbus is 0 at the start. And then as you drive to Cincinnati, you're getting farther and farther away from Columbus. So this would be that. All right. Let's look at this. An increasing function passes through x, y, and mn. What statement correctly compares the 2 points? So an increasing function. Okay, think about what the word increasing means. That means that it's probably going like this. That means that your slope has to be positive. And when we talk about slope, we talk about y2 minus y1 over x2 minus x1. Your change in y over your change in x. So let's look at that situation. Let's say this is x1, y1. This is x2, y2. And let's look at our choices. If x is less than m, then y is less than or equal to n. So x is less than m. That means that our denominator would be negative. Then y is less than or equal to n. Wait, no, hold on. I have that backwards. I apologize. If x is less than m, right? So that would mean we would be doing x2 is larger than x1. So your bottom will be positive. Then y is less than or equal to n. That would mean that your y2 would be greater than or equal to your y1, which would mean you would either get positive or 0. Positive divided by positive makes a positive. So that's it. let's look at our other choices. If x is greater than m, that would mean your x1 is bigger than your x2, which would mean your denominator would be negative. Then y is less than or equal to n. That would give you positive or 0. That would make a negative. If x is less than m, that would mean your denominator is positive. Then y is less than n, which would mean that... Let's think about this. Then y is less than n. That would mean this would have to be positive, which would equal positive. So even you can hear live on this video, I was tricked by this question. Because if you look up here, you can see this is positive, positive, or there's a world where your y2 and y1 are equal, which would mean your numerator would be 0. And it would be 0 over a positive number. But if it's 0, is your line increasing? No, it's not. Your line with a slope of 0 just looks like that. It's a straight line. So A is actually not the correct answer. B results in a negative. D results in a negative. The only thing that results in a guaranteed positive is that if your x is less than your m, so your x2 is bigger than your x1, that produces a positive number, then your y is less than your n. That means your y1 is smaller than your y2, which also produces a positive number. So it's C. Ooh, they got me on that one. That's a tricky question. Carrie goes hiking on a mountain. The graph models her elevation over time. What statement best describes Carrie's elevation during the hike? Okay, so the biggest mistake I see with questions like this is that people interpret elevation somehow as speed. This doesn't represent how fast Carrie is going. What this represents is how their height changes. So they're at the top of a mountain right here, okay? And they're going down. Their height is going down, 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 down. And then let's say they need to stop for a drink of water. This means that their height is not changing. That doesn't even necessarily mean that they stopped. That just means that they're not walking down the mountain. They could be walking on a flat surface. If you're walking, let's say you're walking down the road, right? If you're walking on a sidewalk, your elevation isn't changing. You're just walking on a flat sidewalk. And then they're going down again. So, how would we describe this? A decrease at a constant rate, then no change in elevation for a while, then a decrease again at a faster rate than before. A decrease at a constant rate, then no change in elevation for a while, then a decrease again at a slower rate than before. An increase at a constant rate, then no change. Okay, well, we know it's not increasing to start. We know this is a decrease. So that's gone. An increase at a constant rate, that's gone. So now the question becomes, when they stop and they pick back up, is this a faster rate than this? And the answer is yes. Okay? The steeper the slope, the higher the rate. So let's compare this to, say, like, I don't know. These aren't going to be exact drawings, but if you look at a line with a slope of 1, your line's going to look like that. A line with a slope of 5 is going to look like that. See how this one's a lot steeper? Because you're going up 5 for every 1. While here you're only going up, 1 for every 1. So the more steep a line is, the higher its rate of change. The more extreme its rate of change is. So, this is saying that it's a decrease at a constant rate, then no change in elevation, and a decrease again at a faster rate than before. Because it is more steep. So that is A. A car drives to school at a constant rate, passing a store, a library, and a school along the way. A model of the car's path is shown. Match each building to the graph that models the distance from the car to the building over time as the car travels from point A to point B. Okay. So, Constant rate means that our slope will always be constant, which means it's just going to be a straight line, whether that's diagonal, whether that's horizontal, whether that's lower diagonal, whether that's a straight line up and down. It's going to be constant. Okay? So what this is all about perspective. If you're starting here, the closest thing you are starting to is the store. Okay? Match each building to the graph that models the distance from the car to the building over time as the car travels from point A to point B. Okay? So when you're starting at point A, right, that means you're starting at the store. Your distance to the store will be very, very close because you're pretty much there. And then as you keep driving from A to B, you are getting farther and farther away from the store. So your distance from the store will just go up. Okay, so that's why the store is this first graph. Conversely, with the school, you're starting at the farthest point away from the school. As you're driving down this road, you will never get farther away from the school than where you are at that point. So you're starting at your furthest possible point, and as you get closer and closer to B, your distance from B goes down. So that's why this is this graph. The library's in the middle. So you're starting a medium distance away from the library, then you're going to get to the library, and then you're going to drive away from the library in the process of the school. So you're going to get closer and closer to the library, you're going to get to the library, and then you're going to drive away from the library, and that's why you get this crazy V shape right here for the library. The graph of a function is shown. What statement correctly describes the graph? So this is talking about slope. There are four types of slope. Okay? We have increasing. That's where the line is going up from left to right. We have decreasing. That's where the line is going down from left to right. We have zero, which is a straight horizontal line because you have the zero in the numerator of a fraction, which means that the y is not changing at all. And we have undefined, which is a straight vertical line, which is when you have a zero in the denominator, which means your x is not changing. And you can never divide by zero. Look, you can, if you try to divide by zero, 3 divided by 0, it breaks it. It's its own specific error. It's not even just an error. It has its own error. You can't divide by 0. It just doesn't work. So, this is a simple question of, what does this graph look like? Does it look like increasing, decreasing, 0, or undefined? To me, it looks an awful lot like it's decreasing. So it's decreasing. The cost of a product C remains constant over time T. Use the add arrow tool to create a graph that could represent this situation. The cost of a product C remains constant over time. So let's think about the word constant means. Constant means not changing. It's the same. Think about it even if you have like a younger sibling, right? And you say, oh my God, they just keep constantly talking and talking and talking and they keep it constantly annoying me. That means it never changes. Okay? So if it's never changing, all you gotta do is just pick any of the lines of cost and give it a slope of 0. Just do that. Just a horizontal line. You can put it there. You can put it here. What you cannot do is make any sort of diagonal. No. That means the cost is changing. This is the cost is going up. Okay? This is the cost is going down. This is, I don't even know what's happening. That means time's not moving. Time's at a standstill. That doesn't happen. All you're looking for is one straight horizontal line. That means that if the cost of eggs is $4 in 2021, then the cost of eggs will still be $4 in 2029, which is not how it works. But that's what it's asking you to do. The price is staying constant. The price is staying the same. Mario rides a scooter to his friend's house. His trip is represented in the graph shown. Distance traveled and time. What statement describes Mario's ride? So we have Mario first stayed in one place and then rode at a constant rate. Mario first rode at a constant speed and then he stopped. Mario first rode at one constant speed and then at a faster constant speed. And Mario first rode at one constant speed and a slower constant speed. So Mario first stayed in one place. Well, we can clearly see that he's traveling, right? His distance traveled is going up. So we can already eliminate that he stayed in one place. And we see that his distance traveled never hits a slope of 0. It never levels off. So we know that he never stopped. So now it's already down to he first rode at one constant speed and then at a faster one, or rode at one and then a slower one. And remember, just a couple questions ago, we talked about the steepness of slope. This is more steep than this. That means his rate was significantly higher. This is probably moving at something like 2 miles an hour or 2 miles a minute. Well, this is probably closer to 5 miles a minute. Okay, this is a faster pace. If it is steeper, it is faster. Which graph shows a 0 rate of change? Well, we just went over this. 0 rates of change are just straight horizontal lines. The only one that's straight horizontal line is that. This is undefined. This is not 0. Please note the difference between undefined and 0. Undefined doesn't exist. Remember, divide by 0 error. Okay. All right. Which graph represents a function that is decreasing at a non-constant rate? So, first we have to analyze which of these graphs are decreasing. A is not decreasing at all. It's just constant. D is increasing. It's going from here to here, increasing. So not right. So we're left with B and C. The key word here is non-constant. That means that your slope is changing. Okay. So, here, your slope is pretty much, for the most part, always the same. Hence why it looks like a straight line. Oh, good Lord, how did I do that? Hence why that looks like a straight line. Here, in C, your slope is constantly changing. It's changing at pretty much every new point. You have a different slope. So there's nothing constant about it. So it would be C. When it asks you to look for a function that's decreasing at a non-constant rate, you're looking for a non-straight line. Which graph shows a function that is increasing at a constant rate? Okay. D is not increasing at all. A, in fact, decreases first and then increases. C, in fact, decreases first and then increases. B is just all straight increase. And it's a straight line. So it's a constant rate. So it's B. Deirdre has a new coin bank. For the first 5 days, she deposits the same amount of money in the coin bank. After that, she does not deposit any more money. Which graph could represent the amount of money in her bank? Okay, so if you deposit, let's say you're depositing $1 into your bank every day for the first 5 days. You're going to start with $1. Then you're going to go to $2. Then you're going to go to $3, $4, $5. And then you stop after 5 days. Is your money in the bank changing? No, because you're not adding any new money. So it's still going to be 5, 5, 5, 5, 5, 5. Until you decide to either A, take money out, or B, put more money in. Which of these graphs looks like this? This one. You put in 1, 2, 3, 4, 5, and then you just stop depositing money, so there's just always 5 in there. All right. So that wraps up this standard. That wraps up functions. What a meaty unit that was. All right. So that's going to do it for this standard. I'll be back with more standards. Until then, good luck on your state test.